Hi guys, welcome to math class again. Today we're going to be talking about vertex form, which is very similar to the vertex form of absolute values. If you think back to when we did that, I'm going to say November-ish, that looked like this, the absolute value of x minus h, close absolute value bars plus k. You'll notice how similar they look. This is the vertex form for parabolas or quadratic equations. Very similar. They both have the a, which is like your scale factor or your dilation factor. They both have an h, which is the x value of the vertex. And they both have a k, which is the y value of the vertex. So they're very similar. Also very similar to the exponential one. And again, they all mean the same thing. The a, that's your like stretch or shrink. The h is the x coordinate of the vertex, and the k is the y coordinate of the vertex. We don't really do a lot with the a at this level, but you will do a lot with the a next year in geometry. We really focus more on the h and k, and the h and the k are the vertex. Okay, so today we're going to do when a equals 1, and this is really just another application of completing the square. So if I factor this trinomial, I get x plus 5 squared. That's a perfect square trinomial, so that was pretty simple to factor. And when I do that, I get what's called vertex form just by adding this plus 0. Now, you don't have to have the plus 0 there, but you want to see it because then that tells me that the vertex is -5 because remember it's minus h, so it's the opposite of what it appears to be in the parentheses because the negative of a negative is a positive. So the vertex would be -5, 0. And we can look at that on our graph. I typed them both in, and again, I added the plus 0 just to, demonstrate the point that that vertex is there. So if indeed these two things are equivalent, when I hit the word graph, I'll get the same picture. And hopefully you noticed it came pretty quick, that first it was blue and then it was red. Another way you can check that out is if you look at the table. These tables are equal. I can also show you the vertex. And you'll see the vertex is right here, -5, 0. And it's always symmetrical about the vertex. Symmetrical. All right, so we're going to do another example, and this is going to be a little more difficult because this is not a perfect square trinomial. So what I do is I move the constant term over to the side with the y. And you do that by using the opposite operation. So the opposite of adding is subtracting. And now I say, I wish that this was a perfect square trinomial. If it was a perfect square trinomial, that would mean that I have half of 12, whoops, that should be a 2. Half of 12 is 6, and then 6 squared is 36. So that would have to be a 36. That's called adding the c. Now, remember, this is an equation, so you can't just add a c on one side because then it's no longer an equation. So if I add the 36 on this side, I actually get y plus 2. When I factor it, I get x plus 6 squared, the perfect square trinomial, and then I'm just going to bring that 2 back to the other side. And that's called vertex form, and it's based upon completing the square. And you'll notice that this has a -2 now on this side. So if I just go back and I think about this 34, 34 is 36 minus 2. And that's why I have to have that -2 on the outside, because there is supposed to be a 34 there, not a 36. Okay? I'll show you one more. So I'm going to move the 11. And then I want this to be a perfect square trinomial. So I take the -2 and I divide it by 2. That gives me -1. I take the -1 and I square it. That gives me 1. So this would have to be a 1 in order for that to be a perfect square trinomial. So now I'm going to add the 1 to both sides. So that gives me y subtract 10 equals x minus 1 squared. Remember that -1 comes from when I took half of that. This is an application of completing the square. Then I want it in y equals form, so I have to move the 10 back to the other side. So now again, think about it. In my original standard form equation, I had 11. If I was to work out x minus 1 squared, that would only give me 1. That's why I have to have an additional plus 10 out there, because it has to revert back to the original equation. Let me show you how these are equal on the graphing calculator. Okay, so I go to my y equals, and I'm going to type in my original, and I'm actually going to type in my middle step, okay? And we'll see that these are all equal. X squared subtract 2x, add 11. Now, one of my interim steps, I had the minus 11 next to the y. I can't enter that, because if I was to enter that, that means I would move the equal sign. So I can't enter that. But I'm going to enter my final step, x minus 1 squared plus 10. And now I'm going to hit the word graph. Now pay attention because it comes up pretty quick. Oh, wait, this one's too high. Let's go to the table. Sorry. Okay. Here's my table. Got to get to my vertex. So you'll see here the vertex is 1, 10. They are equivalent. You can't see them on the graph unless you change the window. So I'll change the window just to show you because I really did want you to see it. I'm going to change my min here to maybe a -2, and I'm going to make my max a 20. And now you should see it. There you go. Sometimes when you don't like the view, you just have to change the window a little bit. And there you can see the vertex, which matches the vertex form because the vertex form had a 1, 10. And it definitely looks like a 1, 10. Okay. Let me just do one of the practice ones with you to make sure you're good, and then you're going to do this page on your own. Okay. So the first thing that I do is I move that 2. So y plus 2, and if you want, you could put plus blank, equals x squared plus 6x plus blank. Okay. So now I want this to be a perfect square trinomial. So I take half of 6, which is 3. I take the 3 and I square it, which is 9. So I'm going to add 9 to both sides. That gives me y plus 11 equals, and I'm going to factor that, x plus 3 squared. Remember, it was a perfect square trinomial, so when you factor it, you get the square of a binomial. If I move the 11 back to where I want it for vertex form, I have to subtract it, so I get minus 11, which makes the vertex, and this is an ordered pair, so that's a regular parentheses, -3 minus 11. And I can check this on my graphing calculator. You want to enter the original and the vertex form, verify that it is the correct vertex, and that both equations are equivalent. Thank you for listening. Hope you have a great day. Please reach out if you have any questions at all. Some of these get a little tricky. Actually, really just one of them ends up, because you know that half of 5 is not a whole number. So it's okay. Just use your calculator. Keep mathing on. Hope to see you soon.